Hello viewers, welcome to our channel Career Prep. In this video, we'll learn about the topic clock. Clock is one of the most important topics for government sector entrance exams like UPSC, SBI PO and Clerk, IBPS PO and Clerk, RRB PO and Clerk, SSC, etc. Questions which come from this section are usually very easy to solve if you know the key concepts. This video will explain to you in detail the concept of clocks and the types of questions that may be asked in competitive exams. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. Here is a brief introduction to clocks. The face or dial of a clock is a circle whose circumference is divided into 12 equal divisions called the hour divisions. Each hour division is further divided into 5 equal divisions called the minute spaces. Thus, the whole circumference is divided into 60 equal minute spaces. Look at this diagram of a clock. Now, this is the face of the clock, which is a circle. Now, as you can see here, this circumference of the clock is divided into 12 equal divisions called the hour divisions. Now, as you can see, each hour division is divided into 5 equal divisions called the minute spaces. So, there are 12 hour divisions and each hour division has 5 minute spaces, which means the whole circumference is divided into 60 equal minute spaces. That is 12 multiplied by 5 is 60. So the whole circumference is divided into 60 equal minute spaces. A clock has 3 hands: hour hand, minute hand and second hand, which move around the dial. Now, when it comes to telling time, clocks use the 2 primary hands, the hour hand and the minute hand. The smaller and slower hand is the hour hand, the larger and faster hand is the minute hand. So here you can see the smaller hand is the hour hand, the larger hand is the minute hand, and the third hand is the second hand. Now, while telling the time, clocks usually use only the hour hand and the minute hand. The minute hand moves around the whole circumference of the clock once in 1 hour. The hour hand moves around the whole circumference of the clock once in 12 hours. The minute hand is 12 times faster than the hour hand. Now, the minute hand moves around the whole circumference of the circle once in 1 hour. So the minute hand takes 1 hour to cover the whole circumference of the clock. Now the hour hand, on the other hand, moves only 1 hour division in 1 hour. Supposing the hour hand is at 3, then in 1 hour it moves from 3 to 4. So in 1 hour it has covered only 1 hour division. So to cover 12 hour divisions, the hour hand will take 12 hours. This means the hour hand moves around the whole circumference of the clock once in 12 hours. So the minute hand moves around the whole circumference of the clock once in 1 hour. The hour hand moves around the whole circumference of the clock once in 12 hours. So the minute hand is 12 times faster than the hour hand. Let's now learn about angular values. A clock is composed of 360 degrees and is divided into 12 equal hour divisions. The angle between any two consecutive hour divisions is 360 degrees divided by 12, which is 30 degrees. So the hour hand covers 30 degrees in 1 hour. Now, as you can see here, the clock is divided into 12 equal hour divisions. Now since this is a circle, the clock has 360 degrees. Now there are 12 hour divisions and there are 360 degrees in a clock. This means 12 hour divisions is equal to 360 degrees, which means 1 hour division would be equal to 360 degrees divided by 12, which is 30 degrees. Now supposing the hour hand is at 1. In 1 hour, the hour hand moves from 1 to 2. So during this 1 hour, the hour hand covers 30 degrees. So the angle between two consecutive hour divisions is 30 degrees. So the hour hand covers 30 degrees in 1 hour. Now a clock is composed of 360 degrees and is divided into 60 equal minute spaces. Now angular value of a minute is equal to 360 degrees divided by 60, which is 6 degrees. So the minute hand covers 6 degrees in 1 minute. So as you can see here, since the uh, clock is a circle, there will be 360 degrees. Also you can see that the clock is divided into 12 equal hour divisions, and each hour division is further divided into 5-minute spaces, which means there are 60 equal minute spaces in a clock. So there are 60 equal minute spaces and there are 360 degrees in a clock, which means 60 minute spaces is equal to 360 degrees. So 1 minute space would be equal to 360 degrees divided by 60, which is 6 degrees. This means the minute hand covers 6 degrees in 1 minute. It means the minute hand covers 12 degrees in 2 minutes, 18 degrees in 3 minutes, 24 degrees in 4 minutes, and so on. So in every 1 minute, the minute hand would cover 6 degrees. So what you should remember here is the hour hand covers 30 degrees in 1 hour, whereas the minute hand covers 6 degrees in 1 minute. Let's now learn about the speed of the hands. We know that speed is equal to distance divided by time. So let's find out the speed of a minute hand and the speed of the hour hand. First, let's find out the speed of a minute hand. We know that in 1 hour, the minute hand traverses 360 degrees. This means the distance covered by the minute hand is 360 degrees and the time is 1 hour. We know that 1 hour is 60 minutes. So the time is 60 minutes. Substituting these values in the formula here, we get speed of a minute hand is equal to 360 degrees divided by 60 minutes, which is 6 degrees per minute. So speed of a minute hand is 6 degrees per minute. Let's now find out the speed of an hour hand. Now we know that in 1 hour, the hour hand traverses 30 degrees. So the distance here is 30 degrees and the time is 1 hour. We know that 1 hour is 60 minutes. So time is 60 minutes. Now substituting these values in the formula here, we get speed of an hour hand is equal to 30 degrees divided by 60 minutes, which is nothing but half degree per minute or 0.5 degree per minute. So speed of the hour hand is half degree per minute. So remember that speed of a minute hand is 6 degree per minute and speed of the hour hand is half degree per minute. Let's now learn about comparison of speed of hands. We know that in 1 minute the minute hand moves 6 degrees, whereas in 1 minute the hour hand moves 0.5 degrees. So the difference in the speed is 6 degrees minus 0.5 degrees, which is 5.5 degrees per minute. This means the minute hand is always faster than the hour hand by 5.5 degrees, or the hour hand is always slower than the minute hand by 5.5 degrees. Now we know that in 1 hour the minute hand covers 60 minute spaces, whereas in 1 hour the hour hand covers only 5 minute spaces. This means the minute hand remains 55 minute spaces ahead of the hour hand. This means 55 minutes are covered in 60 minutes. So if 55 minutes are covered in 60 minutes, then 60 minutes are covered in 60 multiplied by 60 divided by 55, which is nothing but 65 5 by 11 minutes. So 60 minutes are covered in 65 5 by 11 minutes. So if both the hands start moving together from the same position, and if the speed of both the hands is the same, then both the hands should coincide after 60 minutes. That is, if both the hands start moving together from the same position, then both the hands should coincide once every hour. But since the speed of the hands is different, it means that uh, 60 minutes are covered in 65 5 by 11 minutes. This means if both the hands start moving together from the same position, both the hands will coincide after 65 5 by 11 minutes, not 60 minutes. Here is a formula to find the angle between the hands of the clock. Theta is equal to modulus of 60h minus 11m divided by 2. Here h is hours, m is minutes, and theta is the angle between the hands of the clock. You have to note here that the modulus represents the absolute value of theta. So, irrespective of whether a positive answer is obtained or a negative answer is obtained, only the value obtained should be considered. Let's now learn about 0-degree angle formation of the hour and the minute hand, and also let's find out how many times the hour and the minute hand coincide in a 12-hour span, and also how many times the two hands coincide in a day. Now, when the minute hand and the hour hand coincide, they are 0 degrees apart. Let's now find out how many times the hour and the minute hand coincide in a 12-hour span. Now a day starts at 12 a.m. So the first ever coinciding of the hands happen at 12 a.m. Now observing the clock, the next coincidence will occur at approximately 5 minutes past 1. Now considering the movement of the minute hand and the hour hand, the times at which the hands coincide in AM and PM approximately are at 12 o'clock, 5 minutes past 1, 2:11, 3:16, 4:22, 5:27, 6:32, 7:38, 8:44, 9:49, 10:55, and again at 12, 5 minutes past 1, and so on. As you can see, the hands overlap approximately after about every 65 minutes. Now, because they overlap about every 65 minutes, you can see that the hour and the minute hands coincide only once between 11 and 1 at 12 o'clock. So between 11 and 1, there's only one coincidence of the hands, which is at 12 o'clock. So between 11 and 1, instead of two coincidences, there is only one coincidence which happens at 12 o'clock. So in a 12-hour span, instead of 12 times, there will be only 11 times when the two hands coincide. So you can say that the two hands coincide exactly 11 times in a 12-hour span. So in 2 hours, there will be only 11 coincidences. Now in a day, there are 24 hours, which means in 24 hours of the day, there will be 22 coincidences. So when the minute hand and hour hand coincide, they are 0 degrees apart. In 12 hours, there will be 11 coincidences. There will be 22 coincidences for 24 hours of the day. Let's now learn about 180-degree angle formation of the hour and the minute hand. Also, let's find out how many times the hands of a clock make 180-degree straight lines in a 12-hour span. Also, let's find out how many times the hands of a clock make 180-degree straight lines in 24 hours of the day. Now, when the minute hand and the hour hand are in opposite directions, they are 180 degrees apart, which means they are 30-minute spaces apart. Because we know 1 minute is 6 degrees, so 30 minutes would be 180 degrees. Now look at this diagram. Here you can see that the minute hand and the hour hand are pointing in opposite directions and they are forming a straight line. Clearly the angle between the two hands is 180 degrees and also they are 30-minute spaces apart. Now let's find out how many times the hands of a clock make 180-degree straight lines in a 12-hour span. Now considering the movement of the minute hand and the hour hand, the times at which the hands are at 180 degrees are at 12:32, 1:38, 2:43, 3:49, 4:54, 6 o'clock exactly, 7:05, 8:10, 9:16, 10:21, 11:27, and then we get back to 12 before it happens again. As you can see here, the hands point in opposite directions once every hour. That is, between 12 and 1, the hands are in opposite directions at 12:32. Between 1 and 2, the hands are in opposite directions at 1:38. Between 2 and 3, the hands are in opposite directions at 2:43 and so on. So clearly the hands point in opposite directions once every hour. This means in a 12-hour span, the hands should point in opposite directions 12 times. But this is not so because between 5 and 7, they point in opposite directions at 6 o'clock only. Now as you can see here, between 5 and 6, the hands point in opposite directions at 6 o'clock. And between 6 and 7, the hands point in opposite directions also only at 6 o'clock. So in these 2 hours between 5 and 7, the hands point in opposite directions only at 6 o'clock. So in these 2 hours between 5 and 7, the hands of the clock point in opposite directions only once, not 2 times. Now, because of this, the two hands point in opposite directions and make 180-degree straight lines exactly 11 times in a 12-hour span, not 12 times. So, the hands of the clock make 180-degree straight lines 11 times in 12 hours. Now in a day there are 24 hours. So in 24 hours they'll make 180 degree straight lines 22 times. So when the minute hand and the hour hand are in opposite directions, they are 180 degrees apart. The hands of a clock make 180 degree straight lines 11 times in 12 hours and hence 22 times in 24 hours of the day. Let's now learn about 90-degree angle formation of the hour and minute hand. Let's also find out how many times the two hands of the clock are at right angles in a 12-hour span. Also, let's find out how many times the 2 hours of the clock are at right angles in 24 hours of the day. Now, when the hour and minute hands are at right angles, it means they are 90 degrees apart, which also means they are 15 minute spaces apart because 1 minute is 6 degrees, so 15 minutes would be 90 degrees. So whenever the hour and minute hands are at right angles, they are 90 degrees apart. Now let's find out how many times the two hands of the clock are at right angles in a 12-hour span. First, let's consider the hour from 12 to 1. The hour and minute hands are at right angles 2 times between 12 and 1. Once at 12:16 and the next time at 12:49. Now consider the hour from 1 to 2. The hour and minute hands are at right angles 2 times. Once at 1:21 and the next time at 1:54. So from 12 to 2, the two hands are at right angles 4 times. 2 times between 12 and 1 and 2 times between 1 and 2. So in this 2-hour time interval from 12 to 2, the two hands are at right angles 4 times. Now if we consider that the two hands are at right angles 4 times in every 2-hour time interval, then they should form right angles 24 times in 12 hours. But actually it happens only 22 times in 12 hours. Let's understand why it is so. Now we have found out that in the 2-hour time interval between 12 and 2, the two hands are at right angles 4 times. Similarly, the two hands are at right angles 4 times in the other 2-hour time intervals like 4 to 6, 6 to 8 and 10 to 12. But in the time interval from 2 to 4 and from 8 to 10, the hands of the clock are at right angles only 3 times instead of 4 times because the minute and the hour hands create right angles exactly at 3 o'clock and exactly at 9 o'clock. Now let's consider the 2-hour time interval from 2 to 4. Now between 2 and 3, the two hands of the clock are at right angles 2 times. Once at 2:27 and the next time at 3 o'clock. Now between 3 and 4, the two hands of the clock are at right angles 2 times. Once at 3 o'clock and the next time at 3:32. As you can see here, the right angle at 3 o'clock is common for the time interval 2 to 3 and 3 to 4. So we can consider this 3 o'clock only once. This means uh, in the 2-hour time interval from 2 to 4, the two hands of the clock are at right angles only 3 times. Once at 2:27, the second time at 3 o'clock, and the third time at 3:32. So in the 2-hour time interval from 2 to 4, the two hands of the clock are at right angles only 3 times, not 4 times. Now let's consider the 2-hour time interval from 8 to 10. Now between 8 and 9, the two hands of the clock are at right angles 2 times. Once between once at 8:27 and the next time at 9 o'clock. Now between 9 and 10, the two hands of the clock are at right angles 2 times. Once at 9 o'clock and the next time at 9:32. Now as you can see, this 9 o'clock is common between 8 and 9 and 9 and 10. So we can consider the 9 o'clock only once. So between 8 and 10, the two hands of the clock are at right angles only 3 times. Once at 8:27, once at 9 o'clock, and once at 9:32. So in the 2-hour time interval from 8 to 10, the two hands of the clock are at right angles 3 times, not 4 times. So in a 12-hour span, the two hands of the clock are at right angles not 24 times but 2 times less, that is 22 times. So the hour and minute hands are at right angles 22 times in 12 hours. Now we know that there are 24 hours in a day. So in 24 hours, the two hands of the clock are at right angles 44 times. So the hour and minute hands of the clock form a right angle for 22 times in 12 hours and hence 44 times in a day. Let's now have a quick recap of a few points. Now you have to remember these points because they'll help you while solving problems on clocks. When the minute hand and the hour hand are at right angles, they are 90 degrees apart, which means they are 15-minute spaces apart. When the minute hand and the hour hand are in opposite directions, they are 180 degrees apart, which means they are 30-minute spaces apart. When the minute hand and the hour hand are coincident, they are 0 degrees apart. When the two hands are in the same straight line, they are either coincident or opposite to each other. Observe here that coincident means both the hands of the clock are together. So when both the hands are together, they form a straight line. When both the hands are opposite to each other also, they form a straight line. So when the two hands are in the same straight line, they are either coincident or opposite to each other. Now the hour and the minute hands of the clock form a right angle 22 times in 12 hours and hence 44 times in a day. The hour and minute hand of the clock coincide 11 times in 12 hours and hence 22 times in a day. The hour and minute hands of the clock are in opposite directions 11 times in 12 hours and hence 22 times in a day. Please remember all these points which will make solving problems on clock much easier. The next important topic under clocks is faulty clock. Let's now understand the concept of faulty clocks. So what is a faulty clock? A clock which shows incorrect time is a faulty or defective clock. If a clock indicates more than the actual time, then the clock is said to be fast or it is gaining time. For example, if a clock indicates 4 hours 10 minutes when the correct time is 4 o'clock, then the clock is 10 minutes fast. If a clock indicates less than the actual time, then the clock is said to be slow or losing time. For example, if a clock indicates 4:40 when the correct time is 5 o'clock, then the clock is 20 minutes slow. Now let's understand the concept of coinciding time. Now, if both the hands start moving together from the same position, then both the hands will coincide after 65 5 by 11 minutes. If the two hands coincide in a time less than 65 5 by 11 minutes, then the clock is too fast. If the two hands coincide in a time more than 65 5 by 11 minutes, it means the clock is too slow. The next topic that we have to learn under clocks is mirror image. So what is a mirror image? The image of an object as seen in a mirror is its mirror reflection or mirror image. In such an image, the right side of the object appears on the left side and the left side of the object appears on the right side. Thus, the mirror image is said to be the lateral inversion of the object. Now, in an analog clock, the time is shown with the help of hour hand and minute hand. Now, if a clock is placed in front of a mirror, the actual time appears differently in the mirror. Now, during some points of time, the hour and minute hands of the clock remain same in the actual and mirror image, like at 6 o'clock, 6:30, 12 o'clock, 12:30. Now, look at these two diagrams of a clock and their respective mirror images. First, let's look at this diagram. Here, the clock shows the actual time of 12:35. Here, the hour hand is between 12 and 1 on the right side of the clock. This is the mirror and this is the mirror image. Now, in the mirror image, the hour hand will be between 11 and 12 and appear on the left side of the clock. Now the minute hand in the actual clock points towards 7 and is in the left side of the clock. Now in the mirror image, the minute hand would point towards 5 and be on the right side of the clock. So the actual time, if the actual time is 12:35, then the mirror image would show the time of 11:25. Now observe this diagram. This is the actual clock, this is the mirror, and this is the mirror image of the clock. Now the actual time in this clock is 6:30. Here the hour hand is between 6 and 7 and is on the left side of the clock. In the mirror image, the hour hand will be between 5 and 6 and will be on the right side of the clock. Now the minute hand is exactly pointing towards 6 and the minute hand is in the straight vertical line. It is neither to the left nor to the right. So in the mirror image, the minute hand will be in the same position, that is, it will point towards 6. So if the actual time is 6:30, then in the mirror image the time would be 5:30. Let's now learn how to solve clock mirror image problems. In clock mirror image questions, either the actual time is given and you have to find its mirror image time, or the mirror image time is given and you have to find the actual time. Now let's understand the method of solving the clock mirror image problems. If the real time is given and its mirror image is asked, or vice versa, then use the following rules. If it is a 12 hours clock, then subtract the given time from 1160 hours. If it's a 24 hours clock, then subtract the given time from 2360 hours. Look at this example. The time in the clock is 4:46. What is its mirror image? So here the time given is 4:46. You have to subtract this time from 1160 to get the mirror image. So 1160 minus 4:46. 11 minus 4 is 7. 60 minus 46 is 14. So the mirror image time is 7:14. Now one thing you have to note and remember is in clock mirror image questions, 12 o'clock is considered as 00 hours. So 12 means 0, 0 means 12. Now look at this example. The time in the clock is 12:35. What is its mirror image? So the time given here is 12:35. Now we know that 12 means 0. So 12:35 means 00:35. So you have to subtract 00:35 from 1160 to get the mirror image. So 1160 minus 00:35. 11 minus 0 is 11. 60 minus 35 is 25. So the mirror image time is 11:25. Now look at the second rule. If the time given is an exact hour, that is, for example, 3 o'clock, 8 o'clock, etc., and the real time is given and its mirror image is asked, or vice versa, then subtract the given time from 12. So if the time is an exact hour, then you have to subtract the given time from 12. Look at this example. Find the mirror image when the exact time shown in the clock was 5 o'clock. So here the given time is 5 o'clock, which is an exact hour. So you have to subtract this time from 12 to get the mirror image. So 12 minus 5 is 7. So the mirror image time is 7. Remember these two rules properly because these will help you while solving clock mirror image problems. Let's understand a few general terms used in a clock. Understand the meaning of these few terms that are used in telling time. 15 minutes past 7 means 15 minutes after 7. So the time is 7:15. 20 minutes to 8 means there are still 20 minutes to 8 o'clock. So 20 minutes less than 8 would be 7:40. Quarter past 6 means 15 minutes after 6 o'clock. So the time is 6:15. Quarter to 6 means there are still 15 more minutes to 6 o'clock, which means the time is 5:45. Half past 6 means 30 minutes after 6 o'clock. So the time is 6:30. 8:30. 9 o'clock means the time is 9. Noon or midday is 12 o'clock. Now AM means after meridian, which is midnight, 12 to 11:59 in the morning. PM means post meridian, which means 12 noon to 11:59 at night. Let's now look at a few types of questions that are asked in competitive exams. The various types of clock questions are: the first type is angle between the hands of a clock. For example, what will be the angle made by the hands of the clock at 8:15? The second time is time at a particular angle. For example, when will the 90-degree angle be formed between 7 o'clock and 8 o'clock? The third type is position of hands of the clock. For example, how many times in a day do the hands of the clock make a 180-degree angle? The fourth type is faulty or defective clock. For example, the clock was set on Thursday at 4 a.m. If the clock gains 20 minutes per hour, what will be the time that the clock shows on Friday at 8:30 p.m.? The fifth type is mirror image based time. For example, if it is 7:20 in the 12-hour clock, then what will be the time in the mirror? Viewers, please go through this video till you have understood the concept. A thorough knowledge of the concept will help you in answering questions correctly on this topic. Also, please do watch a video on clock, angle between hands, solved problems. If you have liked this video, please like, subscribe and share this video. Thank you.